rainforest, for instance, they have many plots, hundreds of plots, spread in the Amazon, for instance. So they know more about the variation, what's happening around the Amazon. To begin with, that is important to say. But they have found that the Amazon is a source of carbon. And they are arguing, source, carbon. I mean, they are capturing carbon. They are not emitting carbon. Sink of carbon. They are capturing carbon.
Okay.
Sorry. They are not emitting carbon. So we did a similar analysis, and we found that, and they say 1 ton per hectare per year in some of the studies, which is a lot. So if you extrapolate that for the entire Amazon, it's a lot. 1 ton per hectare per year. Millions of hectares. But that seems to vary. And there is a variation, of course. There are places where you are losing, places where you are winning, but the average is what they argue. So what we found in Yasuni is that, yes, in average, we find that we are gaining carbon, but not as much as they say, not as much as the average, just 0.3 of tons per hectare. And it's not significant. I mean, it's not like, we have many places where we lose, many places where we win. So, in average, you have a little more. But if you take a random, you choose a random number of plots and do the same, you find that just by random, you find that some of them capture carbon and some of them emit carbon. So it's not different than from zero, in other words. It's like the forest is in equilibrium in a way. You see, we don't have evidence, in other words, that the forest is a sink. We still don't have, even when we, in average, find that yes, but we only have 1 point. So we divide the forest in many small pieces, and then we see, let's see what happened in 625 parts.
And
I don't know if that's clear. I'm explaining myself.
Our writer will come back with questions.
I can tell you another thing, because one important thing that the difference between these two types of studies, the approach that we are following, is that we are considering these small trees, that they are not very significant in terms of the amount of carbon, but they are significant when you are looking at the fluxes, because the fluxes between years are small. I mean, they are small because one hectare of forest can have more than 200 tons of carbon. But the fluxes are 1 ton or less. In average, 1 ton, according to... But what we have seen is that these fluxes are important also in these small trees. So you can overestimate or underestimate a lot these fluxes if you don't consider the small trees. Mm-hmm. So they are not the most important in terms of the stock, but they are important in terms of what is happening in the dynamics of the forest. So we are losing that information if we say, well, we take most of the carbon and the biomass in these big trees, so don't take into account those. But what we argue is that, well, you cannot take if you are interested only in the stocks. But if you want to know what happened in the future and how are those fluxes, you better take into account these small ones.
But you would agree on the fact that young tree, in general, take more carbon than older tree?
It depends, yes. It depends. Because if that young tree is growing, yes. I mean, there are trees that have the conditions to grow faster. Maybe, yeah. There's like a machine, like a factory. They're producing more carbon because they have the chance.
Yeah,
they grow.
They are taking more CO2 and they produce more carbon.
Exactly, yes. Yes. So you can have in some cases, perhaps, there's variation, a lot of variation again. So you can have two trees that have same size, different age. Because the one that is younger was more successful in the forest, receiving more light. Maybe they grow faster, but maybe the other one that have lasted more years in the forest and have the same size, perhaps have a little bit more good density, in terms of good density, a little bit more carbon also. So there are variation in that respect as well. You see? But in general, we assume that that species, same size, more or less the same amount of carbon.
Okay, Renato. Is it possible that we get your email address?
Sure.
So that if needed,